So C4 June 2005 question 6. Okay, really apologise about the noise. It's raining in my conservatory at the moment. Not much I can do about it, I'm afraid. So we start off with parametric equations, okay, with a function for the x coordinate and a function for the y coordinate, and we have to differentiate it. Okay, so here we're differentiating cot t. Well, if you differentiate sine, you get cos. If you differentiate cos, you get minus sine. If you differentiate tan, you get sec squared. So if you get sec squared, then cot must go to minus cosec squared. Okay, so codify with a twist. So tan sec squared, cot minus cosec squared. And so that just becomes that. With this one, you need to think about it being 2, it's a chain rule, 2 something squared gives you 4 that something, okay, reduce the power by 1, and then times by the differential of whatever's inside. Okay, so here this has become sine t, and then we differentiate by what's inside, which is sine t. Remember, this is a lazy way of writing 2 sine t squared. So the 2 goes with it, become 4, this becomes 1, and we differentiate by the inside, we get the cos t. And then I've just divided dy dx by dy dt by dy dx dt, come up with that, and I do some tidying, so I've written this division and rewritten cosec squared as 1 over sine squared, and tied it up to minus 2 sine cubed t cos t. And it wouldn't matter, but I like to put the higher powers towards the end, so I've just flipped those two round. Okay, so that's my answer to pi. Part B, there's 2 ways of doing it, and when I checked the mark scheme, I saw that their first way of doing it is not the way I've done it, but actually it's really quite simple. As soon as I saw the fact that t was pi by 4, I thought to myself, hello, that's 45 degrees, which makes me think of this triangle, which they're basically telling me that sine theta is 1 over root 2, cos theta is 1 over root 2, and tan theta is 1. Because these ones I know, because it's the standard set square triangle, which made feeding the numbers into the x and y coordinates. So I've just fed pi by 4 into these top 2, the function for the x coordinate, the function for the y coordinate, and I got x is 2 and y is 1 when t is pi by 4, fed it into the gradient thing and got minus a half, and then just done y minus y1 equals mx minus x1, and I've got that. So that's my answer to part B. They wrote it in this form, whereby they've doubled everything, 2y equals minus x plus 4, and gave you x plus 2y minus 4 equals 0. But either way is acceptable in the mark scheme. Now in part C, you can see that I've got these 2 functions, and I've got to attach them together. Now, as I've said to you before, as soon as someone tells me that they know what cos t is, right, then I can think of, well, okay, that means that I can make this into a fraction. I can think of the fact that this would be the adjacent, this would be the hypotenuse, and this would be 1 minus x squared, okay? Or sine t, anything. As soon as they tell me 1, then I can use this triangle system to work out all the rest. So the way I did it was to rewrite cot t by itself with the x over 2, and then consider the triangle. Okay, so if cot t, okay, is x over 2, then tan t is the reciprocal 2 over x, which gave me this right angle triangle here, which gave me an expression for sine t. And then I fed it into this equation at the top, and I ended up with the equation. Now they did it differently. They used the fact that 1 plus cot squared is equal to 1 plus cot squared is cosec squared. 1 plus cot. So there's two new ones, isn't there? 1 plus cot squared is cosec squared, and 1 plus tan squared is sec squared. So how can I do that? Well, first of all, then that gives me 1 plus, okay, well, cot t is equal to x over 2, and therefore cot squared is x squared over 4. And here we can see that sine squared t is equal to y over 2, and therefore cosec squared is t is equal to 2 over y, and that gives you 2 over y. And when you rearrange that, you get the same thing as you did before. So if I multiply everything by, if I flip this around and sort it all out, it will give me the same equation. So you can choose which one you think is better. A little word about the domain. You can see here I've got fractions, so maybe there's a division 0 thing happening here, but I can see there's no problem with that because x can never be minus 4. So the domain is any real number.